Write it down, Asa. All right, at the top of page 8, skip the first little paragraph, and I want you to go to where it says moles to atoms and atoms to moles. Everybody see that?
Yeah.
All right, we're talking about what is called Avogadro's number. So fill in the blanks here. This number looks really scary, but all it is just a number with a lot of zeros. It's a really, really big number. And it represents the number of chemical units in 1 mole of any substance. So sometimes that's formula units, sometimes it's molecules, sometimes it's atoms. And for any of those substances, or any of those representative particles, in 1 mole, you have 6.02 times 10 to the 23 of them. Now, just to put in context, I always do this every year, how big this number is. 6.02 times 10 to the 23, so you're going to move the decimal 23 spaces to the right. So it looks like this. 21, 22, no, wait, I'm counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay. Do you understand why we use scientific notation now?
Yes.
Okay. But think about that. That's how many atoms there are in 1 mole of a substance. And a mole is not even a lot. Like if you had a mole of sodium chloride, like salt, that would be like 50 grams. 50 grams could easily fit in the palm of my hand. It's not even close to a pound. Or it's probably like an ounce, maybe. Maybe a little less than an ounce. Okay? But that's how small atoms are. Atoms are impossibly small to think about. But just think about all these particles in your hand, right? All the time. All the time. Right? They're always around you. Okay? I think the number is like in a day, you breathe out like 7.8 times 10 to the 25 molecules of carbon dioxide a day. Right now, yeah, exactly. It's a miracle of chemistry. Breathe it in. Breathe it in. All right, guys. Let's talk about what we're going to do with this number. So let's take a look at the first example problem here. Oh, you know what? We're going to talk about calculators first. Everybody got a calculator out?
Yeah.
Here's how you put these numbers. Oh, jeez. Here's how you put these numbers into your calculators. How many of you guys have 83s or 84s? TI 83, 84. Raise your hand. All right. 1, 2, 3. A couple people keeping it old school. I appreciate that. Okay, that works. Okay. To put this number in on a TI 83 or 84, you're going to type in these numbers. Ready? 1.3. Type in that number. 1.3.
Yeah.
Hit the second button. Comma. The comma's above the 1. Second comma. Okay. All right, hold on. I just want to refocus here. I know, like, this is a serious matter, and I just want to make a plug about calculators. If you are someone who does the calculator swap, like between classes, between you and your friend or whatever, you need to know how to do this on that calculator, or whichever calculator you're using. I can't tell you how many times someone comes to me during common assessments, and they're like, I've never used this calculator before, how do I do a scientific notation? And by then, it's too late. Okay. And I know you guys think it's funny that you're like pulling one over on us, that you actually don't have a calculator, and that you're switching with somebody else. And every year I talk about this, because what happens is, we don't know you don't have one. And then common assessments roll around, and you need to borrow one, and we don't have any more. And by the way, we don't have any more calculators. We had like 100 at one time. We don't have any more calculators because we lend them to people, and then they're not responsible with them. So you need to have a calculator that you call your own, that you know how to use, that you can use on the day of common assessments. Bottom line. It is a worthy investment. So even though it's like, I'm really scared to tell my parents that I lost it, you're going to need this calculator for the next 6 years of your life. Because in college, you're going to take a math class where it's required. So if you want someone to coach you through like how to talk to your parents about losing something, right? I can help you negotiate that conversation. Now, those of you that have 83s and 84s, you put the number in 1.3, second comma. You should see a little E on your screen. Do you see that? Yeah. Now all you do is type in 24. So you would just type in 24. And for Giselle, you have a different calculator. You would do 1.3, and then you hit the CE button there, and then 24, that's the number. Okay. Now, those of you with Inspires, your life is a little easier.
Yay.
You have an EE button. At the bottom left of your calculator, the bottom left, you see that EE button? Type in 1.3, hit the EE button, just hit it once, and then hit 24. And you should have something like this. Did everybody successfully get to this number on your calculator?
Nope.
Okay. You didn't, Jonathan? Type in 1.3. Second. Yep. 24. Enter. No plus. Just enter. Okay. Now, I want to make this clear as well. Don't ever, under any circumstances, put this into your calculator. Because your calculator is not smart. You are much smarter than your calculator. This is a tool. This is a hammer. Okay, you're smarter than a hammer. Well, I mean most of us. But I mean you. I believe that most of you, like 99% of you, I'm just kidding. All of you are smarter than a hammer. Okay? Your calculator thinks, and this is funny because it's so stupid. 1.3 times 10, so that's going to multiply like that's 13, and then they're going to try to put that to the 24th, which is not the same thing as this number, the number we're trying to imitate. So do not, under any circumstances, put that into your calculator, because you will get a wrong answer. You need to use my way. Not my way, the proper way, which happens to be my way as well. Okay, now let's look at sample problem number 1. Let's actually try a problem here. How many moles are in 4.5 times 10 to the 25 atoms of manganese? So what we're going to do is we're going to take this first number and we're going to write it there on our sheets, units and all, everything. 4.50 times 10 to the 25 atoms. 4.50 times 10 to the 25 atoms. Atoms, including the units. Always include your units. Always include your units. We're going to use dimensional analysis. So we multiply by a fraction. On the bottom, what goes on the bottom always? Whatever's here. Okay, whatever you got here, don't even think about it. Just put your units at the bottom. So this is atoms, you put that on the bottom. There you go. Every time. For every chemistry problem you will ever solve. At the top, you put what you want to get to. We want to get to moles. Moles is there. Whatever you put into these fractions has to be equal. The numerator and the denominator must be equal to each other. So 1 mole is equal to how many atoms? What was that number we talked about earlier? What was that number we talked about? 6.02 times 10 to the 23.
Yeah.
And then that's equal to 1 mole. These two things are equal. On your calculators right now, I want you to put this number in. So you're going to start by saying, okay, 4.50 E 25. Multiplied by, open parentheses, 1 divided by 6.02 E 23. Close parentheses. Open parentheses. Oh no, second comma. Let me know if you can't get there on your calculator. Now's the time to ask. You multiplied, you didn't divide. So let's try it again. So type in 4.5.
0.
24, 25.
8.
Okay, now multiply by, open parentheses, type in this fraction, 1 divided by 6.02. Okay, EV, 23, close parentheses, enter again, press equal. There you go.
Yeah.
All right, tell me your full number you got. Marcia, what'd you get on your calculator?
74.7508.
Okay, 74.7508. He is correct. That is not the answer. What's he missing?
Unit.
Units, right? Atoms are going to cancel. You're left with moles. That's your unit. And now, that is not the answer. What's he missing? He's got units, moles.
Does he have to round?
Round? No. I don't want to round. It's already a pretty accurate number. I don't need to round.
That's one.
What are they called? I used to have students call them significant others, which is like funny. Significant digits, right? Significant figures. Okay? So here, we have 1, 2, 3, 4, 5, 6 significant figures. Your number needs to be 3 significant figures, because that's the number you started with. So this is 1, 2, 3 significant figures. So our final answer here, we go 1, 2, 3. Does the 5 round the 7 up or down?
Up.
Up. So it's going to be 74.8 moles. That is your final answer because it has units and because it has significant figures. You need to put your answer in significant figures every single time. All right. Try question 2. Try question 2. No. Okay, so you can pause here.